Imagine weapons that travel at 15,000 miles per hour, invisible aircraft that rewrite air superiority, and soldiers with superhuman capabilities. This isn't science fiction, it's America's military reality. Today on Sci and Why, we're unveiling 10 groundbreaking innovations that are reshaping modern warfare. From hypersonic missiles that can strike anywhere on Earth in minutes to quantum computers that crack enemy codes instantly, these technologies represent the most significant military leap since the atomic age. Prepare to witness the future of American defense dominance. Hypersonic weapons. A missile traveling at Mach 20 can cross an entire continent in under 30 minutes, making every defense system on Earth obsolete. The U.S. military's Dark Eagle hypersonic weapon system represents a quantum leap in strike capability. Officially known as the Long Range Hypersonic Weapon, or LRHW, this boost glide system launches a common hypersonic glide body that separates from its rocket booster and glides toward targets at speeds exceeding Mach 5. The Army successfully tested the complete system in December 2024, marking a critical milestone in America's hypersonic arsenal. Each Dark Eagle battery consists of 4 transporter erector launchers, mounted on modified trucks, each carrying 2 missile canisters. What makes these weapons revolutionary isn't just their incredible speed, it's their unpredictable flight path. Unlike ballistic missiles that follow predictable arcs, hypersonic glide vehicles can maneuver during flight, making interception nearly impossible. The Navy plans to deploy ship-launched variants on Zumwalt-class destroyers by 2025, while the Army aims for full operational capability across multiple batteries. With a range exceeding 1,700 miles and the ability to carry conventional warheads, Dark Eagle transforms America's ability to strike high-value targets anywhere in the world within minutes of launch authorization. Directed energy weapons. The U.S. Navy's laser weapon system can silently destroy incoming missiles, boats, and aircraft, all while remaining completely invisible to the naked eye. Directed energy weapons have transitioned from science fiction to battlefield reality, with the U.S. military leading global development. The Navy's Laser Weapon System, or LAWS, represents the first operational deployment, successfully installed aboard USS Ponce in 2014 as a 30-kilowatt solid-state laser. This invisible weapon can detonate explosives, disable boat engines, and shoot down small aircraft with pinpoint accuracy. The Air Force's Tactical High-Power Operational Responder, or THOR, takes a different approach, using high-power microwaves to disable drone swarms and electronic systems. What makes directed energy weapons game-changing is their virtually unlimited ammunition. As long as there's electrical power, they can continue firing. Each shot costs mere dollars compared to traditional missiles costing millions. The Pentagon has allocated nearly $30 billion over the next decade for directed energy development, with systems planned for land vehicles, ships, and aircraft. Current limitations include power requirements and atmospheric interference, but advances in compact fusion reactors and adaptive optics are rapidly solving these challenges. By 2030, directed energy weapons will likely defend against hypersonic missiles, satellite attacks, and massive drone swarms, providing America with an impenetrable energy shield. Autonomous combat vehicles. Unmanned combat vehicles can now operate for 35 miles per hour across hostile terrain, carrying 1,000-pound payloads while making life-or-death decisions without human intervention. The U.S. Army's Robotic Combat Vehicle program is creating the world's first truly autonomous ground combat force. Despite recent program reassessments due to drone vulnerability concerns, companies like Overland AI have demonstrated remarkable capabilities with their Ultra Vehicle system. During 2025 testing, soldiers controlled these autonomous platforms through 15 live mission scenarios, including kinetic warfare, electronic attacks, and payload deployment. The vehicles successfully navigated complex terrain without GPS, adapted to changing battlefield conditions, and coordinated multi-vehicle operations in real time. 4 prototype systems from major defense contractors, including Textron's Ripsaw, General Dynamics TRX, and Oshkosh's RCV, have undergone extensive evaluation. These platforms can transport supplies, conduct reconnaissance, and engage targets while keeping human soldiers out of harm's way. The modular design allows rapid reconfiguration for different missions, from counter-drone defense to logistics support in contested zones. While the Army continues evaluating cost-effectiveness against drone threats, the underlying technology demonstrates unprecedented autonomous capabilities. Future iterations will likely integrate swarm intelligence, allowing multiple vehicles to coordinate attacks, share intelligence, and adapt tactics dynamically, creating an unstoppable robotic ground force. Advanced cyber warfare capabilities, the digital battlefield. Advanced cyber warfare capabilities mean America's cyber warriors can infiltrate enemy networks, disable critical infrastructure, and manipulate information systems, all from thousands of miles away, and honestly, without ever firing a single shot. U.S. Cyber Command has evolved into the world's most sophisticated digital warfare organization, commanding 133 cyber mission force teams across all military branches. These elite units conduct hunt-forward operations, proactively seeking threats in allied networks, defending U.S. elections from foreign interference, and launching offensive operations against adversaries. The 2021 International Institute for Strategic Studies ranked the United States as the world's foremost cyber superpower, combining unmatched offensive, defensive, and intelligence capabilities. Cyber National Mission Force teams specialize in defending the nation by detecting adversary activity, blocking attacks, and conducting counter-operations in real time. Recent operations include supporting Ukraine's cyber defenses against Russian attacks and neutralizing Iranian hackers in Albania. The challenge lies in force readiness. Many teams operate at only 67 to 75% capacity due to personnel shortages and the complexity of cyber operations. However, ongoing investments in quantum-resistant encryption, AI-enhanced threat detection, and automated response systems are, frankly, revolutionizing cyber warfare capabilities. Future cyber operations will integrate with space-based assets, hypersonic delivery systems, and autonomous platforms, creating a seamless digital physical warfare environment where America can disable enemy capabilities before kinetic weapons are ever deployed. Next-generation stealth aircraft, the Invisible Air Force. Next-generation stealth aircraft are changing the game. The U.S. Air Force has already flown a sixth-generation fighter that, well, breaks every record in aviation history, and China has no idea what hit them. America's Next-Generation Air Dominance, or NGAD program, achieved a historic milestone in 2020 when the Air Force flew its sixth-generation fighter prototype, years ahead of any competitor. The F-47, as it's becoming known, represents a revolutionary leap beyond traditional fighter concepts. This tailless, highly stealthy aircraft features adaptive engines producing 35 to 40,000 pounds of thrust, enabling sustained speeds above Mach 2, with operational ranges exceeding 1,500 miles. The aircraft will operate in both manned and unmanned configurations, serving as the central brain for collaborative combat aircraft drone swarms. Advanced AI systems enable real-time coordination with multiple unmanned platforms, creating an integrated air dominance network. The B-21 Raider bomber complements this capability, offering next-generation stealth at $692 million per aircraft, significantly cheaper than the $2 billion B-2 Spirit. With its optionally manned design and ability to carry both nuclear and conventional weapons, the B-21 provides strategic reach across the Pacific. 3 B-21s are currently in flight testing with operational deployment planned for 2027. These platforms will integrate directed energy weapons, hypersonic missiles, and AI-enhanced sensors, creating an invisible, unstoppable air force that can strike anywhere while remaining undetected. Soldier Augmentation Systems, the Enhanced Warrior. Soldier augmentation systems are here, and U.S. soldiers now wear augmented reality headsets that let them see through walls, around corners, and through smoke, while coordinating with AI-powered battlefield networks in real time. The Army's Integrated Visual Augmentation System, or IVAS, transforms individual soldiers into enhanced warriors with honestly superhuman capabilities. Built on Microsoft HoloLens technology, IVAS provides thermal and low-light vision, rapid target acquisition, aided target identification, and augmented reality overlays directly in the soldier's field of view. During 2024 testing with the 82nd Airborne Division, soldiers accumulated over 40,000 hours of operational data across company-sized training events. The ruggedized system withstands combat conditions while providing real-time mapping, mission planning, and after-action review capabilities. Soldiers can rehearse operations in virtual environments, coordinate with team members through digital displays, and access critical information without taking their eyes off the battlefield. The Fight Rehearse Train system allows unlimited scenario practice anywhere, anytime. Beyond visual augmentation, military research explores exoskeletons for enhanced strength and endurance, biometric monitoring for health optimization, and neural interfaces for seamless human-machine integration. Future soldier systems will integrate with autonomous vehicles, drone swarms, and cyber warfare platforms, creating a networked warrior capable of dominating any battlefield environment. These enhanced soldiers represent the evolution of human combat capability, where technology amplifies natural abilities to superhuman levels. Quantum computing for defense. Well, it's kind of a game changer. Quantum computers can crack encryption codes that would take traditional computers billions of years to solve, completing the task in mere minutes. The Pentagon's quantum computing initiative represents the most significant advancement in military computation since the digital revolution. With over $100 million committed to quantum technologies, the Department of Defense is developing applications in three critical areas: quantum sensing, quantum computing, and quantum communications. DARPA's Robust Quantum Sensors Program, or ROQS, creates military-grade sensors that maintain performance under harsh battlefield conditions, enabling detection of submarines, nuclear materials, and concealed threats with, honestly, unprecedented precision. Quantum computers will revolutionize military logistics by optimizing complex supply chains, analyzing vast intelligence datasets, and solving previously impossible strategic problems. The Air Force allocated $2.5 million to develop quantum software for military logistics optimization, while the National Quantum Initiative provides $3 billion in federal funding for quantum research. The technology's most concerning application involves breaking current encryption systems. Quantum computers could potentially crack the codes protecting military communications and classified data. To counter this threat, the Pentagon is implementing post-quantum cryptographic infrastructure, ensuring data security in the quantum era. Future quantum applications include quantum radar systems immune to stealth technology, quantum communication networks impossible to intercept, and quantum-enhanced artificial intelligence systems that process battlefield information at unprecedented speeds. Drone swarm technology, the autonomous Air Force. Drone swarm technology is, honestly, changing the game. The Pentagon's Replicator program is set to deploy thousands of autonomous drones that can coordinate attacks, share intelligence, and adapt tactics, all without human control. America's drone swarm technology has evolved from experimental concepts to operational reality, with the Pentagon's Replicator program leading global development. The $500 million initiative aims to deploy thousands of inexpensive autonomous drones by August 2025, focusing on autonomous collaborative teaming and resilient network communication systems. The PERDIC system, operational since 2016 and developed by MIT Lincoln Laboratory, has produced over 670 drones capable of coordinating with F/A-18 fighter jets in complex swarm operations. These systems demonstrate unprecedented collective intelligence, where individual drones communicate in real time to navigate GPS jamming, radio interference, and adverse conditions while still maintaining synchronized operations. Recent testing shows swarms can overwhelm traditional defense systems through sheer numbers and coordinated tactics. The Swedish Armed Forces unveiled software that controls up to 100 drones simultaneously, while US forces tested swarms across 15 live mission scenarios, including reconnaissance, electronic warfare, and payload delivery. The technology's military advantage really lies in cost-effectiveness. Swarms of expendable drones provide affordable alternatives to million-dollar missiles while offering superior flexibility and resilience. Looking ahead, future swarm applications include autonomous logistics, perimeter defense, and coordinated strikes against high-value targets, creating an unstoppable aerial force that adapts and evolves in real time. Space-based weapons, the ultimate high ground. Space-based weapons are, well, ushering in a whole new era. The U.S. Space Force is developing 6 different types of space weapons, including anti-satellite systems and orbital interceptors that can strike targets anywhere on Earth. America's space warfare capabilities represent the ultimate military high ground, with the Space Force developing comprehensive orbital weapon systems. Current acknowledged capabilities include ground-based communications jammers that interfere with satellite signals, but classified programs likely extend far beyond public knowledge. The Golden Dome Missile Defense Initiative includes space-based interceptors designed to counter ballistic missiles and potentially hostile satellites during conflict. Advanced robotic systems demonstrate satellite capture and manipulation capabilities, with companies like Maxar and Northrop Grumman developing arms capable of engaging non-cooperative satellites in orbit. The Air Force Research Laboratory's Starfire range utilizes sodium guide stars for precise satellite tracking and imaging, while directed energy weapons in space could disable spacecraft through laser or microwave attacks. Space-based kinetic weapons remain theoretical but technically feasible, offering global strike capabilities with minimal warning time. The challenge lies in international treaties prohibiting weapons of mass destruction in space, though conventional weapons face fewer restrictions. Future space weapons will likely integrate with hypersonic delivery systems, quantum communication networks, and AI-controlled platforms, creating an orbital defense network capable of protecting American interests while projecting power globally. Control of space increasingly determines terrestrial military dominance. AI-powered command systems, the digital general. AI-powered command systems honestly are changing how wars are fought. Artificial intelligence systems can now process battlefield intelligence, coordinate multi-domain operations, and make strategic decisions faster than any human commander, revolutionizing military leadership itself. The U.S. military's artificial intelligence revolution extends beyond individual weapons to comprehensive command and control systems that process information and coordinate operations at superhuman speeds. AI-enhanced sensors provide real-time battlefield awareness, analyzing satellite imagery, drone feeds, and electronic intelligence simultaneously to create comprehensive operational pictures. Machine learning algorithms predict enemy movements, optimize resource allocation, and recommend tactical adjustments based on evolving conditions. The integration of AI with existing military systems creates force multipliers, where human commanders leverage artificial intelligence to manage complex multi-domain operations spanning land, sea, air, space, and cyberspace simultaneously. Advanced AI systems coordinate between hypersonic weapons, drone swarms, cyber operations, and space-based assets to execute synchronized campaigns impossible for human planners alone. Natural language processing enables seamless communication between AI systems and human operators, while predictive analytics anticipate logistical needs and maintenance requirements before problems occur. Future AI command systems will integrate quantum computing power, enabling real-time analysis of massive datasets and strategic planning across multiple scenarios simultaneously. These digital generals don't replace human judgment but amplify it exponentially, creating military decision-making capabilities that process information, coordinate responses, and adapt strategies at the speed of light. From hypersonic missiles that, honestly, redefine global strike capability to AI systems that think faster than human commanders, these 10 innovations represent America's technological dominance on tomorrow's battlefield. Each system doesn't just enhance existing capabilities, it fundamentally transforms how warfare is conducted. If you're fascinated by these game-changing technologies and want to explore more cutting-edge military innovations, hit that like button, share your thoughts in the comments, and subscribe to Sci and Why for more deep dives into the technologies shaping our world. Thanks for watching, stay curious. When radar screens go dark and missiles streak through the night, only one thing matters: which fighter emerges victorious. Today on Sci and Why, we're unveiling 10 aircraft that turned pilots into legends and battles into history lessons. These aren't just machines, they're the apex predators of the sky, each one a masterpiece of engineering that changed warfare forever. From the Cold War's deadliest hunters to today's stealth assassins, these fighters didn't just participate in history, they wrote it. McDonnell Douglas F-4 Phantom II, the supersonic workhorse. The F-4 Phantom II was so versatile that it became the only fighter jet ever used simultaneously by the United States Navy, Air Force, and Marine Corps, while setting 15 world records in the process. The McDonnell Douglas F-4 Phantom II stands as America's most prolific supersonic fighter, with 5,195 aircraft built between 1958 and 1981. Originally designed for the United States Navy as a fleet defense interceptor, the Phantom proved so exceptional that it was adopted by all three American military branches. The twin-engine tandem two-seat fighter could reach speeds exceeding Mach 2.2, and carry over 18,000 pounds of weapons on 9 external hardpoints. What made the F-4 revolutionary was its beyond visual range combat capability, using advanced radar and missile systems instead of traditional dogfighting tactics. During the Vietnam War, the Phantom claimed 280 aerial victories, more than any other American aircraft in the conflict. All 5 American servicemen who became aces during Vietnam achieved their status flying F-4s. The aircraft's unique design initially omitted an internal cannon, relying entirely on missiles for air-to-air combat. This philosophy reflected the era's belief that future aerial warfare would be fought at long range using guided weapons. The F-4 set numerous world records, including absolute speed and altitude achievements, proving its exceptional performance capabilities. Its robust construction allowed it to serve in multiple roles: air superiority fighter, ground attack aircraft, and reconnaissance platform, making it truly the workhorse of Cold War aviation. Mikhail Gurevich MiG-21, the flying coffin. The MiG-21 became the most produced supersonic aircraft in history, with over 11,000 built, yet earned the terrifying nickname Flying Coffin due to its deadly safety record. The Mikhail Gurevich MiG-21, NATO codename Fishbed, represents the pinnacle of Soviet mass production philosophy applied to fighter aircraft. First flying in 1956, this single-engine interceptor was designed to be simple, fast, and inexpensive to manufacture. The MiG-21's delta wing configuration and powerful afterburning engine enabled speeds exceeding Mach 2, making it a formidable opponent despite its small size. Over 11,000 MiG-21s were produced across multiple variants, serving with over 50 air forces worldwide. The aircraft proved its combat effectiveness during the Vietnam War, where nimble MiG-21s consistently outmaneuvered heavier American fighters like the F-4 Phantom. Its small radar cross-section and exceptional maneuverability made it difficult to detect and engage, leading to numerous successful engagements against technologically superior opponents. However, the MiG-21's reputation was tarnished by significant safety issues, particularly in Indian Air Force service, where over 170 pilots and 40 civilians lost their lives in accidents since 1970. The aircraft's afterburning engine operated dangerously close to its surge point, making it vulnerable to flameouts from even minor foreign object ingestion. Despite these challenges, the MiG-21 remained in production until 1985, and continues serving with several air forces today. Its Chinese-built variant, the Chengdu J-7, extends the design's legacy into the 21st century, proving the enduring value of Soviet engineering philosophy. McDonnell Douglas FA-18 Hornet, the versatile warrior. The FA-18 Hornet was the first fighter jet designed from the ground up to excel equally in air-to-air combat and ground attack missions, earning its unique FA designation. The McDonnell Douglas FA-18 Hornet revolutionized naval aviation by combining fighter and attack capabilities in a single airframe. Derived from the Northrop YF-17 in the 1970s, the twin-engine Hornet was specifically designed for aircraft carrier operations while maintaining exceptional versatility. The aircraft entered service with the United States Navy and Marine Corps in 1983, quickly proving its worth in multiple combat roles. Its first combat action came during the 1986 Operation El Dorado Canyon strikes against Libya, where Hornets successfully performed both air-to-air and ground attack missions. The FA-18's advanced fly-by-wire flight controls and excellent aerodynamic design provided exceptional handling characteristics, making it equally capable of dogfighting and precision bombing. During Operation Desert Storm in 1991, Hornets demonstrated their versatility by shooting down Iraqi MiG-21s and attacking ground targets in the same missions. The aircraft's reliability and maintainability made it ideal for carrier operations, where space and resources are limited. The United States Navy's Blue Angels flight demonstration team adopted the Hornet in 1986, making it the longest-serving aircraft in the squadron's history. The FA-18's modular avionics architecture allowed continuous upgrades throughout its service life, keeping it relevant against evolving threats. Its success led to the development of the larger F/A-18E/F Super Hornet, which continues the legacy of multi-role excellence in modern naval aviation. Dassault Rafale, the French omni-role master. The Dassault Rafale is, honestly, the only fighter jet in the world officially designated as omni-role, capable of performing every conceivable military aviation mission from a single platform. The Rafale really represents France's independent approach to advanced fighter design, which was born out of disagreements with European partners over the future European fighter aircraft program. So, when France withdrew from the multinational project back in 1985, Dassault went ahead with an ambitious solo development program that would eventually create one of the world's most capable multi-role fighters. The twin-engine Canard Delta Wing aircraft first flew in 1986 and entered service with the French Navy in 2001, followed by the Air Force in 2006. The Rafale's Omnirole designation reflects its ability to perform air supremacy, interdiction, reconnaissance, ground support, anti-ship strikes and even nuclear deterrence missions, all without modification. Some of its advanced features include the RBE-2 active electronically scanned array radar, the Optronique Secteur frontal infrared search and track system, and direct voice input controls, all of which were developed domestically in France. The aircraft proved its combat effectiveness during its first deployment in Afghanistan in 2007, where it performed precision strikes using laser-guided bombs. Subsequent operations against ISIS in 2014 and Libya in 2011 really demonstrated the Rafale's versatility in modern conflicts. Its export success includes orders from Egypt, India, Qatar, Greece, Croatia, Indonesia, and the United Arab Emirates, which just goes to show its international appeal. With over 260 aircraft delivered and continuous production still ongoing, the Rafale truly represents France's technological independence and engineering excellence in military aviation. Eurofighter Typhoon, the European collaboration. The Eurofighter Typhoon required 4 nations, 3 decades, and wow, over $20 billion to develop. But it created Europe's most advanced air superiority fighter. The Typhoon actually emerged from the complex European fighter aircraft program, representing this kind of unprecedented cooperation between the United Kingdom, Germany, Italy, and Spain. Development kicked off in 1983, when these nations set out to create a next-generation air superiority fighter to counter Soviet threats. The program managed to survive France's withdrawal in 1985, and despite numerous political challenges, produced one of the world's most advanced combat aircraft. The twin-engine Canard Delta Wing fighter first flew in 1994 and entered service in 2003, featuring cutting-edge technologies like thrust vectoring, advanced radar systems, and sophisticated electronic warfare capabilities. The Typhoon's aerodynamic design provides exceptional maneuverability, and its EJ-200 engines enable supercruise capability, meaning sustained supersonic flight without afterburners. The aircraft's distributed manufacturing approach involves all 4 partner nations, with final assembly lines in multiple countries. Advanced avionics include the Captor-M mechanically scanned radar, which is currently being upgraded to the Captor-E active electronically scanned array system for even better performance. The Typhoon achieved initial operational capability with the Italian Air Force in 2005, followed by the RAF in 2006. Combat deployments include air policing missions over the Baltics, operations in Libya, and ongoing quick reaction alert duties across Europe. Export success includes sales to Austria, Saudi Arabia, Oman, Kuwait, and Qatar, which really demonstrates international confidence in European aerospace capabilities. The Typhoon program stands as the largest European defense collaboration in history, proving that multinational cooperation can, in fact, produce world-class military technology. McDonnell Douglas F-15 Eagle, the undefeated champion. The F-15 Eagle has achieved, get this, over 104 aerial victories without a single loss in air-to-air combat, making it the most successful fighter jet in modern history. The McDonnell Douglas F-15 Eagle stands as the ultimate air superiority fighter, designed in response to intelligence reports of advanced Soviet aircraft in the late 1960s. This twin-engine, twin-tail fighter first flew in July 1972 and entered service in 1976, immediately establishing itself as the world's premier air-to-air combat aircraft. The F-15's exceptional thrust-to-weight ratio allows it to accelerate vertically right after takeoff, while its advanced radar and missile systems provide beyond visual range engagement capability. Its remarkable combat record includes victories by the Israeli Air Force during the 1982 Lebanon War, where F-15S shot down numerous Syrian aircraft without loss. During the 1991 Gulf War, USAF F-15S achieved 36 of the 39 confirmed air-to-air kills, including 5 Iraqi fighters shot down in a single day. The Eagle's success really comes from its combination of superior performance, advanced avionics, and exceptional pilot training. Its APG-63 radar system, later upgraded to the APG-70 and APG-63 V3 variants, provides outstanding detection and tracking capabilities. The F-15's large internal fuel capacity enables extended combat missions without refueling, while its robust construction allows high-G maneuvering in combat. The aircraft also spawned the F-15E Strike Eagle variant, adding significant ground attack capability while maintaining air-to-air excellence. Despite being designed back in the 1970s, the F-15 remains in production with the latest F-15X variant, proving the enduring value of its fundamental design. The Eagle's undefeated record and continued relevance make it without a doubt the gold standard for air superiority fighters. Sukhoi Su-27, the Soviet Skydancer. The Sukhoi Su-27 can perform the legendary Cobra maneuver, pointing its nose 90 degrees upward while maintaining forward flight, a feat impossible for most Western fighters. The Sukhoi Su-27, NATO codename Flanker, represents the pinnacle of Soviet aeronautical engineering and the USSR's answer to American fourth-generation fighters. Development began in 1969 as a direct response to the F-15 Eagle, with the goal of creating a long-range air superiority fighter capable of defending Soviet airspace. The twin-engine single-seat fighter first flew in 1977 and entered service in 1985, immediately establishing itself as one of the world's most capable combat aircraft. The Su-27's massive size, comparable to the F-15, houses large internal fuel tanks providing exceptional range exceeding 3,000 kilometers. Its powerful AL-31F engines and advanced aerodynamic design enable super maneuverability, including the famous Cobra maneuver where the aircraft can point its nose skyward while maintaining forward momentum. The fighter's sophisticated radar and missile systems include the N001 Mayak radar and capability for up to 10 air-to-air missiles, making it a formidable beyond-visual range combatant. The Su-27's combat effectiveness was demonstrated during various conflicts, including successful engagements against advanced Western aircraft. The aircraft's robust construction and simple maintenance requirements made it ideal for Soviet operational philosophy. The Su-27 spawned an entire family of variants, including the Su-30 multi-role fighter, Su-33 naval variant, and Su-35 advanced air superiority fighter. Export success includes sales to China, India, Indonesia, and numerous other nations, with licensed production in China as the Shenyang J-11. The Su-27's combination of range, payload, and maneuverability continues to influence modern fighter design, really proving Soviet engineering excellence. Lockheed Martin F-22 Raptor, the Invisible Predator. The F-22 Raptor is so stealthy that its radar signature is, honestly, smaller than a marble, while its super cruise capability allows sustained Mach 1.5 flight without afterburners. The Lockheed Martin F-22 Raptor represents the pinnacle of stealth fighter technology and is the world's very first fifth-generation combat aircraft. Born from the Advanced Tactical Fighter program back in the 1980s, the F-22 was designed to ensure American air superiority well into the 21st century. The twin-engine single-seat fighter first flew in 1997 and entered service in 2005, incorporating revolutionary technologies including stealth, supercruise, and advanced avionics integration. The Raptor's angular design and radar-absorbent materials reduce its radar cross-section to that of a small bird, making it virtually invisible to enemy sensors. Its Pratt & Whitney F-119 engines with thrust vectoring provide exceptional maneuverability and enable supercruise, sustained supersonic flight without afterburners, giving it a significant tactical advantage. The F-22's APG-77 active electronically scanned array radar can track multiple targets simultaneously while remaining undetected through low probability of intercept technology. Advanced sensor fusion combines radar, infrared, and electronic warfare data into a comprehensive battlefield picture displayed on high-resolution cockpit screens. The aircraft's internal weapons bays maintain stealth characteristics while carrying AIM-120 AMRAAM and AIM-9 Sidewinder missiles, plus a 20mm cannon for close combat. Despite its advanced capabilities, F-22 production was limited to 195 aircraft due to high costs and changing threat perceptions. The Raptor achieved its first air-to-air kill in 2023, shooting down a Chinese surveillance balloon off the North Carolina coast. Its combination of stealth, speed, and situational awareness makes it the most advanced air superiority fighter ever built. Grumman F-14 Tomcat, the Fleet Defender. The F-14 Tomcat could simultaneously track 24 targets and engage 6 of them with its Phoenix missiles from over 100 miles away, capabilities unmatched by any other fighter of its era. The Grumman F-14 Tomcat served as the U.S. Navy's premier fleet defense interceptor for over 3 decades, designed specifically to protect carrier battle groups from Soviet bomber threats. The twin-engine two-seat fighter first flew in 1970 and entered service in 1974, featuring revolutionary variable sweep wing technology that optimized performance across all flight regimes. The F-14's most distinctive feature was its AWG-9 radar system and AIM-54 Phoenix missile combination, capable of engaging multiple targets simultaneously at unprecedented ranges. The aircraft's variable geometry wings automatically adjusted from 20 to 68 degrees sweep, based on flight conditions, providing excellent low-speed handling for carrier operations and high-speed performance for intercept missions. Powered by 2 Pratt & Whitney TF-30 or General Electric F-110 engines, the Tomcat could reach speeds exceeding Mach 2.3 while carrying up to 6 Phoenix missiles. The F-14's combat debut came with the Iranian Air Force during the Iran-Iraq War, where it achieved numerous victories against Iraqi aircraft. U.S. Navy Tomcats saw action in various conflicts, including the 1981 Gulf of Sidra incident where 2 F-14s shot down Libyan Su-22s, and operations over Afghanistan and Iraq. The aircraft's large size and powerful engines made it ideal for long-range patrol missions over vast ocean areas. Hollywood immortalized the F-14 in the 1986 film Top Gun, making it one of the most recognizable military aircraft in popular culture. Despite its capabilities, the Tomcat was retired in 2006, replaced by the smaller but more versatile F/A-18E/F Super Hornet. The F-14's legacy lives on as the ultimate fleet defender, proving that specialized aircraft can really excel in their intended roles. General Dynamics F-16 Fighting Falcon, the Viper. The F-16 Fighting Falcon has been produced in greater numbers than any other Western fighter aircraft, with over 4,600 built and serving in 25 air forces worldwide. The General Dynamics F-16 Fighting Falcon revolutionized fighter aircraft design through its lightweight, multi-role philosophy and became the most successful Western fighter export in history. Developed in the 1970s as part of the lightweight fighter program, the single-engine F-16 first flew in 1974 and entered service in 1978. The aircraft's innovative design featured the first production use of fly-by-wire flight controls, relaxed static stability, and a side-mounted control stick. The F-16's bubble canopy provides exceptional visibility, while its reclined ejection seat helps pilots withstand high G-forces during aggressive maneuvering. The fighter's General Electric F-100 or Pratt & Whitney F-110 engine provides excellent thrust-to-weight ratio, enabling sustained 9G turns and impressive climb performance. Advanced avionics include multi-mode radar, head-up display, and hands-on throttle and stick controls that reduce pilot workload during combat. The F-16's modular design allows easy configuration changes for different missions, from air-to-air combat to precision ground attack. Combat experience includes Israeli operations in Lebanon, where F-16S achieved numerous air-to-air victories and extensive use during Operation Desert Storm. The aircraft's reliability and cost-effectiveness made it attractive to numerous allied nations, leading to licensed production in Belgium, Netherlands, Turkey, and South Korea. Continuous upgrades have kept the F-16 relevant against modern threats, with the latest Block 70 and 72 variants featuring advanced radar and electronic warfare systems. The Fighting Falcon's success demonstrates that smaller, less expensive fighters can be highly effective when properly designed and equipped. Its combination of performance, versatility, and affordability ensures continued service well into the 2030s. From the record-breaking F-4 Phantom to the invisible F-22 Raptor, these 10 legendary fighters represent the evolution of aerial warfare over 6 decades. Each aircraft pushed the boundaries of technology and tactics, shaping the skies above countless battlefields. If you're fascinated by these incredible flying machines and want to explore more aviation legends, hit that like button, share your favorite fighter in the comments, and subscribe to Sci and Y for more deep dives into the aircraft that changed history. Thanks for watching. Keep reaching for the skies. When NASA's computers started receiving impossible data from the edge of our solar system, scientists couldn't believe what they were seeing. After 47 years of silent travel through the cosmic void, Voyager 1 has transmitted discoveries that challenge everything we thought we knew about interstellar space. Today, on Sci and Y, we're unveiling the shocking revelations that have left astronomers questioning the very nature of our universe. From mysterious humming sounds to unexplained cosmic phenomena, these findings will change how we view our place in the galaxy forever. The impossible mission that defied all odds. Voyager 1 was designed to last just 5 years, yet it's still transmitting data after nearly half a century, making it humanity's most successful space mission ever. In 1977, NASA launched what seemed like a routine planetary exploration mission. Voyager 1 and its twin, Voyager 2, were built using 1970s technology with computer systems containing just 70 kilobytes of memory, less than a single smartphone photo today. Originally designed to study Jupiter and Saturn during a rare planetary alignment, these spacecraft were expected to go silent by 1982. Instead, they embarked on humanity's greatest journey into the unknown. The mission capitalized on a once-in-176-year gravitational alignment that allowed the spacecraft to use planetary gravity as cosmic slingshots, accelerating them toward the outer solar system. What began as a 5-year mission has become a 47-year odyssey that redefined our understanding of space. Today, Voyager 1 travels at 38,000 miles per hour through interstellar space, sending back data from regions no human-made object has ever explored. The fact that this 1970s technology continues functioning in the harsh environment of deep space represents one of engineering's greatest triumphs. Crossing the final frontier into interstellar space. On August 25, 2012, Voyager 1 became the first human-made object to leave our solar system, entering a realm where the sun's influence ends and true interstellar space begins. The moment Voyager 1 crossed the heliopause, the boundary between our solar system and interstellar space, marked a historic milestone for humanity. At 11 billion miles from the sun, the spacecraft detected a dramatic change in its environment. The solar wind, a stream of charged particles flowing from our star, suddenly dropped to nearly zero, while cosmic radiation increased threefold. This transition wasn't gradual, it was like stepping from a protected harbor into an open ocean. The heliopause acts as our solar system's shield, protecting us from the galaxy's intense radiation. Beyond this boundary lies the interstellar medium, a vast expanse filled with remnants from ancient star explosions, cosmic dust, and mysterious phenomena that scientists are only beginning to understand. Voyager 1's instruments detected strange magnetic field fluctuations and unexpected particle densities that contradicted existing models. The spacecraft found itself in an environment where the familiar rules of our solar system no longer applied. This crossing represented more than a technical achievement. It was humanity's first step into the galactic neighborhood, opening a new chapter in space exploration. The mysterious humming sound from the void. Voyager 1 detected a low, persistent humming sound in the supposed silence of interstellar space, a discovery that has scientists completely baffled about what's creating this cosmic symphony. In the vacuum of space, sound shouldn't exist. Yet Voyager 1's instruments detected something extraordinary, a continuous, low-frequency humming emanating from the interstellar medium itself. This wasn't sound as we understand it on Earth, but rather vibrations in the sparse gas and plasma that fills the space between stars. The humming appears to be generated by the interstellar medium's interaction with cosmic phenomena, creating a kind of cosmic background music that permeates our galaxy. Scientists describe it as similar to the sound of wind through trees, but occurring in a medium millions of times thinner than Earth's atmosphere. The discovery challenges our understanding of how energy propagates through space, and suggests that interstellar space is far more active than previously thought. These vibrations might be caused by stellar winds from distant stars, shockwaves from supernovae, or even more exotic phenomena we haven't yet identified. The humming varies in intensity and frequency, suggesting it responds to changes in the local interstellar environment. This cosmic soundtrack provides scientists with a new way to study the structure and dynamics of our galaxy, turning Voyager 1 into an interstellar seismograph. The heliopause's shocking behavior. The boundary of our solar system isn't the stable barrier scientists expected. Instead, it's moving, shifting, and behaving in ways that completely contradict our models of how space works. The heliopause, which is our solar system's protective boundary, has revealed itself to be way more dynamic and unpredictable than anyone imagined. Rather than maintaining a steady position, this cosmic border actually fluctuates dramatically, sometimes moving billions of miles in relatively short periods. Data from Voyager 1 and 2 shows the heliopause exhibiting strange angles and irregular shapes that just defy current theoretical models. Back in 2014, NASA's Interstellar Boundary Explorer satellite detected unusual brightening of energetic particles, which suggested massive disturbances in the boundary region. These irregularities simply don't match existing predictions about how the solar wind should interact with interstellar space. The heliopause's movement might even explain why Voyager 1 and 2 reached interstellar space 6 years apart, even though they followed similar trajectories. Scientists have observed the boundary creating shock waves and turbulence that ripple through both the solar system and interstellar space. This dynamic behavior suggests our solar system is more like a living organism than a static structure, constantly responding to galactic forces we're only beginning to understand. The implications are pretty profound. If our solar system's boundary is this unstable, what does that mean for the protection it provides against cosmic radiation? Electronic confusion in the cosmic deep. So, in May 2023, Voyager 1 began transmitting garbled, incoherent data instead of scientific measurements, as if the spacecraft was suffering from electronic dementia in the depths of space. 46 years into its mission, Voyager 1 experienced what NASA engineers described as electronic aphasia. The spacecraft's attitude articulation and control system started sending random, meaningless data instead of coherent status reports. From Earth's perspective, it honestly looked like Voyager 1 was losing its ability to communicate effectively, much like how a person with aphasia struggles to form coherent sentences. The mystery deepened when engineers realized that, despite the garbled communications, Voyager 1's radio signal remained strong and stable, which meant the spacecraft was still functioning normally. Its scientific instruments just kept operating without any awareness of the communication problem, and the fault protection system, designed to put the spacecraft in safe mode during emergencies, never activated. After a lot of investigation, NASA discovered the problem. The control system had switched to a computer that had been dormant for years, basically trying to use obsolete hardware to process modern commands. The solution required sending precise instructions across 15 billion miles of space to reactivate the correct computer system. This incident really highlighted the incredible challenge of maintaining 1970s technology in the harsh environment of interstellar space, where cosmic radiation constantly bombards the spacecraft's electronic systems. Surviving the impossible, technology beyond its limits. Voyager